Welcome back to the Subspace Games YouTube channel. Today we're going to be talking about the difference between local coordinates and global coordinates. Now, people that are not familiar with moving between the two, this can be kind of a confusing subject. And even people that have used the different coordinate systems, sometimes it can get confusing. When to use each coordinate system and what the differences are. So I just wanted to cover this in a little bit of detail here. I did go ahead and add some more features to the game, but I haven't had a chance to do the video. And actually, let me just load this up so I'll show you what we're working towards, because the next two videos we'll be covering some stuff that is directly related to the changes that I've made to the game. So what I did is I created a basic chase cam. Let me just show you what it looks like here. What am I looking for? Display. Let's change this. Okay, let's run it. So you can see it's just some basic. Doesn't work super well because I haven't put the collision detection and whatnot in as for the camera, so it can go through the wall. But anyways, we do quite a lot with the coordinate system when we're trying to do a chase cam. A lot of stuff with vectors. So we're going to talk about coordinate systems today, and then the next video we'll do vectors, and then we'll have the groundwork that we need to look at the camera and what we're doing as far as the chase camera goes. So like I said, I haven't done the video on how to do the code on this, so I'm not going to put it up on the website yet, and you'll just have to bear with me and be patient. So let's close that up. Yes, I really want to quit. Okay, so the difference between global and local are basically in the names. So the global coordinate system is what you can think of as being the coordinate system for everything within the scene. So when we put the ball into the scene, we're going to put it at a certain coordinate. So if we put it at 0, 0, 0, it's going to be right there at the intersection of the three axes, the X, Y, and Z axis. Every time we put an object in, we can set its translation, and we're positioning things in relation to each other, and that's in the global sense. So everything is positioned within that global system. Now each object has its own coordinate system. So if you can imagine the ball, no matter where the ball is in the scene, its local coordinates, the location for the local coordinates, it's going to be 0, 0, 0. And if something is directly to the right of the ball, then it's going to be along the x-axis, even if that object, maybe the ball, is somewhere else in the scene. So this is getting kind of confusing. So let me show you. I went ahead and modeled some stuff in Blender here to kind of help describe what's going on. So we have our square in the middle, and the square represents our object. And so in Blender uses different coordinates than what ShiVa uses, so I put on the screen what the ShiVa coordinates are. Now you Blender users are going to look at this and go, wait, no, that's not the way it works. But this is ShiVa. This is the ShiVa system that I'm explaining. So just suspend all the the Blender stuff for now. So in ShiVa, straight up is the positive y-axis, down is the negative y-axis, off to your left is the negative x, and off to your right is the positive x. Now as we rotate our view around a little bit, maybe we'll make this a little bit easier. So the positive z, that's coming out of the screen straight at your forehead. The negative z is going into the scene. So yeah, we'll rotate a little bit around, and when we're dealing with ShiVa, I made the front of this box pointed because it's important for us to recognize that the object, wherever it's facing, is the negative z. Okay, so that's the axis that we're dealing with. So right now our object is in sync with the global axis, the global coordinate system. So I don't know if you can notice this, but on the axes I have like these little arrows that are kind of tucked in. Well, that's the tips of the local coordinate system. So you can see that they're lined up. The blue, the green, and the red, everything's lined up together. So the object is sitting at 0, 0, 0. And so in this case, the local coordinate system and the global coordinate system are the same because the object is right at the origin in the global system, and it's lined up perfectly so that it's facing the negative z direction, and so everything is perfectly lined up. Well, what happens if, let's say we select this object here, let's grab it, and let's move it around. So let's move it over here. All right, so now we haven't rotated or anything, we've just moved it. Now you can see it's come off the axis, the axes in several different directions. So let's say, let's try and get a good view here. Let's go to the above the top view. So you can imagine that in Shiva, the coordinates for this might be, you know, negative, what is this, 5, and then positive 3. So the point that this thing is at is negative 5, positive 3. But in the local coordinate system, it's still at 0, 0. Because the local coordinates have not moved. You'll notice that the axes for the local object are still right in the center of that local object. So if we were to say, let's find an object that is, you know, x equals 3, y equals 0, according to the local coordinate system. Well, for that, we'd go over in the x direction 3 units, and then we would go, we said y equals 0, so that would be right here, right at the end of this arrow. However, in the global coordinate system, x is 3, y is 0 would be all the way over here. We'd go over 3 units, and then up 0, so it'd be over here. So that's how the two coordinate systems differ. That one is in relation to the object, and the other one is in relation to the entire game. Now it gets even more tricky when we start doing some stuff like this, where we start doing some rotations. Okay, now we're really screwed up, right? Because not only is the x direction, the x-axis somewhere else, but now it's skewed. Now it's not even lined up with the global coordinate system. And so this is where people get into trouble, because there are some functions that will take an angle or take some kind of measurement, and let's say rotation. So if you do a rotation but you use the local coordinate system, then you can be caught in this loop where you're constantly rotating. For example, let's pull in this other layer that I've got here. So we have this angle here. I set this to 10 degrees, and this is in the local system. So if you say rotate 10 degrees and then you set the coordinate system to local, well, the problem is it starts to rotate, and for the first time it goes to rotate, it says, okay, let's head to 10 degrees local. Well, okay, now we got to 10 degrees local. Well, it didn't actually ever really reach there, because as you notice, that 10 degrees that's in relation to the local coordinate system is still 10 degrees off wherever you're facing. So you keep rotating around and around and around, because the object can never reach that 10 degrees in relation to the local coordinate system. And so that's the most common thing that I've seen, and especially when I try to do some things myself, is you try and move to a location in a local coordinate system, but you're never really able to get there, because every time you move, you've now switched to, you know, that angle is moving with you, and so it's like a dog chasing its tail. So I hope this explanation of the local coordinate system compared to the global coordinate system was helpful. I hope that I didn't confuse people any more than they have been. And we're going to take a look at this in more detail as we start to look at a game. And just keep in mind, when we start making references to those local or global coordinate systems, that's what's going on, and I'll try to emphasize what's going on when we do it, and why we're using the local system versus the global system, and how it plays into the programming of the game. Anyways, like I said, the next video we're going to be talking about vectors, and they're really important when we talk about coordinate systems, because as with anything, you need to have a point of reference. So as we start talking about vectors, we have to know, are we talking about a vector in reference to the global system or the local system? It really does make a difference. So stay tuned for that next video, and I'll try and knock that out as quickly as I can so that we can move on to getting the chase cam up and running. Thanks for tuning in, and I'll see you next time.